Now let us consider the concept of potential difference. Now in an electric field, let me consider 2 points A and B located at a distances of dA and dB from a point charge located at a point P. So what is P? P is the location of a point charge Q, and A is the first point and B is the second point, between which we are interested in developing an expression for the potential difference. Now general expression for potential difference, if you observe, is simply it is V is equals to minus integral E bar dot dl, and this V is nothing but the potential difference. Now let us consider the starting point is A. So if I apply the same equation here, RA into RA to RB, or we can as well take dA to dB. So here if I consider RA as the distance of A from P, and if I consider RB as the distance of B from P, so I can take from RA to RB, E bar dot dl would be your expression for the potential difference. Now potential difference I can write as VB, second point minus first point, that is VB minus VA. Now what is VB? VB is the potential due to the point charge at Q at point B. And what is VA? The potential at point A due to the point charge at P. So VB minus VA is the potential difference. Now let us evaluate this RHS. So E is, we all know that due to a point charge, E is given by Q by 4 pi epsilon naught R square into R. So let us substitute the same formula here. So it is simply RA to, of course, minus RA to RB. E bar is simply Q by 4 pi epsilon naught into R square into, I can as well replace the length element with dr. So it is Q by 4 pi epsilon naught, which is a constant, into, of course with the minus sign outside, into minus 1 by R from RA to RB. So it is now we can cancel 1 minus and minus here. So you are remained with what? Q by 4 pi epsilon naught into 1 by RB minus 1 by RA. So VB minus VA is equals to Q by 4 pi epsilon naught into 1 by RB minus 1 by RA. So in general, if you observe the first term, VB is taken to be similar to Q by 4 pi epsilon naught into RB. So I can say the general formula for potential at any point is Q by 4 pi epsilon naught into R. So where R is the distance between the location of the charge and the point where we are interested in determining the potential V. Okay, so in general, the formula for potential difference is VB minus VA is equals to Q by 4 pi epsilon naught into 1 by RB minus 1 by RA. So this formula is very, very useful in solving the problems which we are going to do in the forthcoming problems. Okay, now let us do one or two problems. Before going to problems, let us evaluate the expression for potential difference due to line charge. Line charge distribution. Due to point charge, E bar is given by Q by 4 pi epsilon naught R square into AR cap. Okay, so into AR cap, and here it will be E bar is equals to, if you remember, rho L by 2 pi epsilon naught R into AN cap. So this expression is to be used for determining the potential due to a line charge distribution. So what is, let us develop the expression now. So V is equals to rho, now just replace minus, E is replaceable with rho L by 2 pi epsilon naught R into DL, I can replace it with the dr, and my RB, RA to RB. Now if I go for the common terms, rho L by 2 pi epsilon naught into integral dr by R with a minus sign from RA to RB. So if anybody is interested in evaluating integral dr by r or simply dx by x, it is ln of x, that is the natural logarithm of x. So based on that, I can write it as, of course, strictly speaking, constant, integration constant, and that integration constant can be assumed to be equal to 0. So based on that assumption, minus rho L by 2 pi epsilon naught into ln of r from RA to RB. Okay, so it is simply minus rho L by 2 pi epsilon naught into ln RA, strictly it is RB minus ln RB minus ln RA, or simply ln RB by RA. Okay, with a minus sign. So if I wanted to take this minus sign inside, so it is simply rho L by 2 pi epsilon naught into ln of RA by RB. So that means the distance between the charge location. So what is RA? RA is the distance between the starting point, okay, starting point of the line charge distribution, and the point where we are interested in calculating V, and point reference point of calculating V. So we can simply say reference point of V. Similarly, what is RB? It is the ending point of the potential difference distribution and the reference point of V. So of course, how to calculate RA and how to calculate RB, once we do one numerical, you can get a clear-cut idea how to determine RA and how to determine RB. So once we have a problem, you can get an easily what is RA and what is RB and how to calculate them. Okay, forthcoming part of the lecture, we are going to do 1 or 2 problems based on this concept. To understand the concept of potential, let us work out one numerical in page number 106, practice exercise 3.11 of Elementary of Electromagnetics by Sadiku. Okay, so if you want, you can refer this problem in Sadiku in page number 106. Now, he says that a point charge is located at origin and its value is 5 nanocoulombs. He says a point charge is located at origin and its value is 5 nanocoulombs. If V is equals to 2 volts, that is if the potential at 0, minus 6, minus 8, if it is 2 volts, then he is asking you to determine the potential at A minus 326, B 157, and the potential difference between the 2 points VA and the points A and B. So first of all, whenever a problem on potential is being given, so it is always better for you to draw a electric field. So assume an electric field in the form of a circle, okay, and he first says that a charge is located at origin. So let me call this as origin, and how much is the charge located here? It is simply 5 nanocoulomb, and we have got one for the first point of reference is given. So if VA is 0, minus 8, that means the first point of reference is P. So let us say that P is the reference point here, and it is 0, minus 6, minus 8. Okay, so 0, minus 6, 0, 8 is the point of reference for us, and it says the point of reference is A. So let me say it as A, somewhere A, and its value is, and its coordinates are minus 3, 2, 6. The coordinates of A are minus 3, minus 2, and 6. Similarly, the another reference point we have got is B. So B is it is the coordinates are 1, 5, and 7. Okay, now let us work out this problem. Of course, the answers are given to be for the first case it is 3.928 volts, and it is 2.696 volts, and here it is 1.233 volts. So these are the answers for the 3 cases. Now let us work out with this problem. Now he says that the potential at P is at this point P is 2 volts. So the charge is located at origin. So we need to take the basic formula is we are interested in, let me say, first calculating the potential difference between P and A. So VA minus VP is equals to, basic formula is Q by 4 pi epsilon naught into, of course, 1 by RA minus 1 by RP. 1 by RA minus 1 by RP. Okay, and he gave that the potential at this point P is 2 volts. Okay, so we need to determine the potential at A. So that's what is he asking. So the potential at A he is asking, and so let me say it as VA minus Vp, the potential at point P is given as 2 volts. So Va minus 2 is equals to, Q is given to be 5 nanocoulomb. So 5 nano means 5 to 10 power minus 9, and by previous lectures knowledge we can say 1 by 4 pi epsilon naught is 9 into 10 to the power of 9 into, Now let us evaluate what is Ra. So you should understand carefully the meaning of what is Ra. So Ra is what? And the distance between the point we are considering and the location of the charge. So what is the location of the charge? Actually it is at origin. Okay, so this charge is located at origin, and the point of interest is minus 3 to 6, which is A. So the distance between these 2 points, if you calculate, you are getting it to be 7. So it is Ra is simply under root of 3 square plus 2 square plus 6 square. How I got this? The Ra is the distance between the point A and origin O. So it is simply, if you observe, you will be getting it as 7. Okay, next, what about the second distance Rp? It is the distance between the point P and O. So if you observe the distance between the points P and O, simply Rp is simply under root of 0 square minus 6 is plus 6 square plus 8 square, and if you determine its value, you will be getting it as 10. So you will be getting it as 10, and so it is simply 1 by 7 minus 1 by 10. Okay, now obviously Va minus 2 is equals to, it is 10 and 10 power minus 9 and 10 power plus 9 will get cancelled. Okay, so you are having 5 into 9 is 45. 45 into 1 by 7 minus 1 by 10. So it will be 1 by 7 minus, it is simply 3 by 70. Okay, so Va is, if you observe 3 by 70 into 45 would give us 1.928 plus 2. So it is simply Va is 3.928, which is our volts, of course, which is our required answer. Okay, so in this way we can determine Va, and let us start with Vb. So in the same way you can as well determine Vb. So here the crux or the important vital point here is to write how to write the potential equation. Okay, so in terms of the potential difference, it is Va minus Vp between the points P and A. Similarly, between this, if I write the same in terms of potentials, then it is Q by 4 pi epsilon naught is common anyhow, into between 2 points, it is 1 by Ra minus 1 by Rp is the potential difference. Okay, so this is the formula for potential difference in terms of the distances, and this is the formula for potential difference in terms of the original potentials. Okay, so now let us determine on same lines the distance, the potential at the point B. Now if I apply the same logic here, Vb, so for getting Vb I am using Vb minus Vp is equals to Q by same expression I am writing into, the only change is since we are determining since we are taking Vb minus Vp, here 1 by Rb minus 1 by Rp. Now how to determine Rb is the next question. So how to determine Rb? Rb can be determined as the distance between the point B and the location of the charge, which is origin. So if you observe, it is simply under root of 1 square plus 5 square plus 7 square, and if you calculate this, it will be simply under root of 75. Okay, so now let us use this here. So Vb minus Vp is 2 given in the question itself is equals to, of course I am directly writing it as 45 because here it is 5 into 9. So 45 into 1 by Rb is root 75 minus 1 by Rp is 10. So if you calculate the RHS, Vb minus 2 is equals to, so it is simply 0.696. Okay, so it is 0.696. If you want, you can also verify this, 0.696, and from this I can simply say that Vb would be 2 plus 0.696. It is 2 plus 0.696, and you will be getting it as 2.6 for us. Okay, so in this way we can calculate Vb also. Okay, so how to determine the potential between the points AB? So VAB is simply VB minus VA. Okay, So it is the second point volt potential minus first point potential, that is simply 2.696 minus 3.928. So if you calculate this, you will be getting it as minus 1.232 volts, which is approximately numerically equal, but opposite in sign, because I think he might have taken A as the first point and B as the A as the second point and B as the first point. So I think he might have got the value as VBA. So numerically our answer is correct. So we can assume that our answer is correct here. So here we have taken VAB, we got it as minus 1.232, and obviously VBA would be plus 1.232. Okay, so let us work out one more problem on line charge distribution to calculate the potential, so that you can get a very good amount of grip on the concept of potential. Example number 3.11, page 104 of Sadiko. Okay, in this problem it says that a point charge 5 nanocoulomb is located at minus 340, and a line charge distribution y is located at y equal to 1 and z equal to 1, and its value is 2 nanocoulomb per meter. Okay, so if we have here we have got two distributions. One is a point charge distribution and one is a line charge distribution. So due to these two distributions, if in this condition, if the potential is 0 at origin, find the potential at phi 0 1. Okay, so if he says that potential is 0 at origin, find the potential at phi 0 1. This is the first bit. Second bit says that if the potential is 100 volts at B121, find the potential at C minus 2 phi 3. Similarly, if same bit says that if the potential is minus 5 volts at 0, that is the origin, find the potential difference between the points B and C, which is VBC. Now let us work out this problem initially. So as usual, we need to assume an electric field. Okay, we need to assume a circular electric field like this, and we need to incorporate each and every source or point, whatever is given in the problem. So first let us start with the 5 nanocoulomb. So in the given problem, he mentioned this point as A, okay, and he mentioned this point as B. So and one more point as C. So let us take the point as P. Okay, so at a point P, which is nothing but minus 3, 4 and 0, the charge is 5 nanocoulomb. So the point charge is located at point P, and the coordinates of point P are minus 3, 4 and 0. And here the line charge is, I am printing the line charge like this. It is passing through the points y equal to 1 and z equal to 1. So I can mention the line charge coordinates as x11. Why x11? It is immaterial at what point ever on x-axis we take. We are not concerned with the x coordinate when we are considering the line charge distribution. This point already I have explained in while determining the electric field due to line charge distribution. Now let us name this as some q. Okay, let us name this as some q. Now we have got 4 points. One is origin, which is O00. Okay, and we have got A is given to be actually 5, 0, 1, and B is given to be 1, 2, 1, and C, some point C here, you assume it, and it is minus 2, 5 and 3. Okay, so these are the different points in the given question. Okay, now let us start the problem. So in the first bit, he says that the potential is 0 at origin. The potential is 0 at origin. Find the potential at at A phi 0 1. So that means we need to find the equation. We need to determine we need to put the potential difference equation for points O and A. Okay. So on LHS, let us start with LHS. Potential difference between A and O is simply VA minus VO. VA minus VO. Okay, that is equals to, now what is the potential difference due to point charge? Basically it is ln, if you remember, it is ln RA by RB, that is the point distance by second point distance, that is RA by R naught in this case, RA by R naught plus. Now coming to the potential difference due to point charge, it is q by 4 pi epsilon naught into, if you remember, it is 1 by the first distance minus 1 by the second distance. So it is simply 1 by Ra minus 1 by R naught. The potential difference due to point charges is given by 1 by R naught minus 1 by Ra. Okay. So now let us find out each and every value in this. Now let us come to Ra. So how to calculate Ra in this case, or simply instead of since we avoid confusion, rho A by rho naught. Now let us start with rho A. Now what is rho A? It is clearly the distance between. It is the distance between the source. What is the source here? The line charge. So source between, it is the distance between line charge and the point A. Neglecting x coordinate. Why should we neglect x coordinate? Is because it is passing through y equal to 1, z equal to 1. So we need to, whatever is the x coordinate, we can neglect that. So based on that concept, rho A would be the distance between 0, 1 and 1, 1. Okay. So if you observe the distance between 0, 1 and 1, 1, it is simply 1. How it is 1? It is under root of 0 minus 1 whole square plus 1 minus 1 whole square. So it is simply 1. So rho A is 1. And what about rho naught on similar lines? It is the distance between O and the line charge distribution, neglecting x coordinate. So if I neglect x coordinate here, the point is 0, 0, and here the point is 1, 1. So obviously the distance between the point 1, 1 and 0, 0 would be root 2. So rho naught value is simply root 2. So let us substitute these values here. So if I substitute that, ln of course here rho L by 2 pi epsilon naught, if you observe not. Okay, it is rho L by 2 pi epsilon naught. So now let us substitute each and every value in this equation. And of course, let us evaluate R naught also. So what is R naught? R naught is the distance between O and the location of point charge. So if you observe, R naught is simply 5. How I got it as 5 is simply 0 minus of minus 3, it is 3 square plus 4 square under root. Next, coming to RA. RA is simply the distance between these 2 points. The distance between P and the P, which is the location of point charge, and A. So it is 5 minus of minus 3, it is 8. 8 square plus 4 square plus 1 square. So it under root of 8 square is 64 plus 4 square is 16 plus 1 is 81. So it is 9. Okay, so let us substitute all these values. So VA, which is to be found out, minus V naught is given to be equals to 0 there. Okay, so he says that VA is 0. The potential at O is 0. So that is V naught I can write as 0. Is equal, and 1 by 2 pi epsilon naught is 18. 18 into the given value of it is 2. So what happens to the 10 powers? 10 powers gets cancelled because 1 by 2 pi epsilon naught is 18 into 10 power minus 9. Sorry, 18 into 10 power 9, and since the line charge distribution is given as rho L equal to 2 nano, means 2 into 10 power minus 9. So here plus 9 and here minus 9 gets cancelled, so you are remaining with only 18 into 2. And of course here it is ln of rho A is 1 and rho naught is 2. So ln of 1 by root 2 plus Q is, of course, the given value of Q is 5 nanocoulomb. So it is 5 into 10 to the power of 5 into 9. Simply I am writing 5 into 9. I am not writing the 10 powers because they two get cancelled each other. Divided by into 1 by R naught is 1 by 5 minus 1 by 9. Okay. So let us evaluate this. So VA is equals to minus 12.477. Next, now if I calculate this, what is it I am going to get is plus 45 into 9 minus, I am taking LCM here, 9 minus 5 by 45. So in total it is simply minus 12.477 plus 9 minus 5 is 4. So it is minus 8.477 volts. So this is the calculation for VA. So in this, if you understand how to apply this formula, then the remaining part is very, very easy. So you should know the physical meaning of what is rho A and rho naught. So I'll tell you once again, rho A is the distance between the point A and the line charge distribution, neglecting one coordinate which is not mentioned in the points. Okay, so in the point here y and z are mentioned, obviously x is not mentioned, so I am not considering the x coordinate of both a and the line charge distribution. Similarly, here we need to calculate rho naught also for the distance between O and the line charge distribution. And coming to this formula already we have done in the previous problem, so you need not worry about this. Okay, now on the same lines we'll work out the working for B. In this B bit, he says that the potential is 100 volts at B, 1 to 1. So this is one reference point we have. Find the potential at C of -2, 5 and 3. That means in the previous case, he has given the reference point as O and he asked us to determine the potential at A. So that's why we have taken the potential difference equation between the points A and O. On same lines, here what should be done? We need to take since the potential at B is given and since he is asking the potential at C, we need to connect a potential relation between B and C. So on single lines, if I can write VC minus VB. VC minus VB is equals to, now this will become rho L by 2 pi epsilon naught into ln. On similar lines, what is the first distance is coming in the numerator, so here it is rho C will come in the numerator and rho B would be coming in the denominator. Okay, plus Q by 4 pi epsilon naught into the first distance is coming in the first position here, so obviously here it is 1 by RB minus 1 by RC. Now let us calculate what all the different parameters involved in this equation. Okay, so if I wanted to calculate all these parameters, first let us start with rho C. Okay, so first let us start with rho C. Rho C is what is the distance. Rho C is the distance between the point C and the line charge distribution. Now, what every Tom, Dick and Harry says that it is the distance between these 2 points, but we need to exclude the x coordinate because here in the given line charge distribution, x coordinate is not specified. So obviously we can neglect the x coordinate of both the line charge distribution and the point C. So if I take only y coordinates and z coordinates into consideration, is it not under root of 5 minus 1 it is 4 square and 3 minus 1 is 2 square. So in total it is under root of 4 square plus 2 square, which is equals to root 20. Okay, on similar lines, if I want to calculate the distance between points B and the line charge distribution, directly I can say that it is under root of 2 minus 1 whole square plus 1 minus 1 whole square, which is simply 1. So rho B would be 1 here in this case. And coming to RB, now let us calculate RB. What is RB? RB is the distance between the point B and the point charge. So B is 1 to 1 and point charge is -3, 4, 0. So if I evaluate the distance between these 2 points, it is simply 1 minus of -3 is 4 square. Okay, so under root of 4 square plus 2 square plus 1 square. So it is how much? It is simply root of 21. Similarly, what would be RC? RC would be under root of -2 minus of -3 is 1. 1 square plus 5 minus 4 is 1 square plus 3 minus 0 is 3 square. So it is root 11. So root 21 root 21 is RB and root RC is root 11. So now let us substitute all these values in this equation. Okay. So from this, what is VC? VC is unknown and we need to determine VC. So VC minus 100 is equals to, now let us substitute the values given. So rho L by 2 pi epsilon naught, as in this case, I can directly write it as 18 into 2. So how I got 18 into 2? 1 by 2 pi epsilon naught is 18 into 10 power 9 and rho L is given to be 2 nano, which is 2 into 10 power minus 9. So in total 18 into 2 would be the replacement for rho L by 2 pi epsilon naught and into ln of RC, rho C we got it as root 20. So it is root 20 by 1. So rho B is 1. So ln root 20 plus what is 1 by 4 pi epsilon naught is 9 into, yeah, what is Q given here? Nano. So I need not write the 10 powers. Simply I'll write 5 into 9 into here what is the distance as if you calculate, it is 1 by RB. RB is root 21 minus 1 by root of 11, 50.175 volts. Okay, so from this VB we know it has 100. So 100 minus VC is equals to 50.175 volts. So VC would be 100 minus 50.175 volts, which is simply 49.83 volts. Okay, so this is the final answer for us for VC. Okay, now on similar lines you can calculate the value of VBC, and the answer for VBC is simply we can get it as VBC VC minus VB, which is VBC is VC minus VB, which is VC we got it as 49.8 something minus 100 is given here, so it is minus 50.2 volts. So this is the C bit for us. So in this way we can determine the potential at any point which is conditionally given. That means at one point, what if the potential is specified for us, how to determine the potential at the another point. So this is a best example for a conditional potential problem. Now let us derive a relation between E and V, that is the electric field intensity and the potential. Now the potential element dV from calculus can be written as, so if I have three orthogonal directions x, y and z, okay, in terms of the derivative changes in x direction and y direction and z direction, I can get the expression, the total change in the potential as dou v by dou x. This is the change in x direction into dx. So what does this term indicate? This term indicates the change of the potential in x direction. Similarly, we have got two more directions, that is y and z. So it is simply dou v by dou y into dy plus dou v by dou z into dz. Now we know that the expression for the electric field intensity is always potential per unit distance. So what is so what is E? E bar is Q by 4 pi epsilon naught into d square, and if I write it as Q by 4 pi epsilon naught into d into 1 by d. So the term in the bracket is V. So potential by distance. So potential by distance is always equals to electric field intensity E bar. So in similar way, dou V by dou x, I can say that it is the electric field intensity in the x direction, and dou V by dou y would be the electric field intensity in the y direction, and dou V by dou z is the electric field intensity in the z direction. So I can, of course, with a negative sign. So I can write it as minus E x into dx plus minus ey into dy into minus ez into dz. So this cross product, this dot product, I can as well represent it as minus of ex into ax cap plus ey into ay cap plus ez into az cap into dot of dx ax cap plus dy ay cap plus dz az cap. Okay, so this vector in the first bracket I can replace it with the minus e, and it is simply dot dl. So I can say that dv is equals to minus e bar dot dl. And if you observe from this, I can write V equals to minus integral E bar dot dl. This is the integral equation for V. And on a similar lines, let me derive an expression for electric field in terms of potential. So we can write E as Ex into Ax cap plus Ey into Ay cap plus Ez into az cap. Now, of course, Ex, I can replace it with minus dou v by dou x into Ax cap plus dou v by dou y. So dou v by dou y stands for Ey into Ay cap plus dou v by dou z into Az cap. Okay. Now this I can as well write it as minus, just I am throwing out v outside the brackets, it is dou by dou x of Ax cap plus dou by dou y of Ay cap plus dou by dou z of Az cap into v. So the one which is in the term in the bracket is delta. So E is equals to minus del into v. So I can say from this equation that the gradient of the potential, scalar potential, will give us the electric field intensity. So from this equation I can say that the negative gradient of the potential function in a field will give us its electric field intensity. Let us work out one numerical on determining E bar and the work done given the potential function. So as an example, let us work out example number 3.12 on page 108 of Sadiko. In this he says that the potential given function is given so and so, okay, and he is asking you to determine the electric flux density d bar at 2 pi by 2 0, okay, and he is also asking us to calculate the work done in moving a 10 microcoulomb charge from 2 points, from A 130 degrees 120 degrees to B 490 degrees and 60 degrees. Okay, so the first part is very easy. Once we know how to expand the gradient, we can determine its flux density. So let us work out flux density problem. E bar is equals to minus del into V, del V, simply it is the gradient of V. So it is simply minus del V. So the given system of coordinates is by the given three coordinates r, theta and phi, we can come to a conclusion that it is the spherical coordinate system. So we need to expand the gradient of V in spherical coordinate system. The gradient expansion in spherical coordinate system is minus of, this minus is carried here from here. So del V is expanded as dou V by dou R into AR cap plus 1 by R into dou V by dou theta into A theta cap plus 1 by R sin theta into dou V by dou phi into A phi cap. So now let us substitute the given V there. So 10 is a common value. So you are having minus 10 into dou by dou R of sin theta cos phi by R square into AR cap plus 1 by R into dou by dou theta of sin theta cos phi by R square, next plus 1 by R sin theta, of course, into A theta cap plus 1 by R sin theta into dou by dou phi of sin theta cos phi by R square, okay, into of course A phi cap. Okay, so now let us expand this. Minus 10 into, so here the only term which contains R is 1 by R square. So the differential of 1 by R square is minus 2 by R cube. So you are having this function as minus 2 sin theta cos phi by R cube into AR cap. Okay, next the only term which contains theta in this expression is sin theta. So the derivative of sin theta is cos theta. So you can replace this expression with cos theta cos phi by R cube into A theta cap. Next, similarly, the only term which contains, since sin theta is constant here, the derivative is with respect to phi. So sin theta terms can be taken constant. So I can directly cancel away sin theta and sin theta. Now, so the only term which obviously contains here is phi is cos phi. So what is the derivative of cos phi? It is minus sin phi. So it is minus sin phi by R cube into of course A phi cap. Okay, so if I multiply this with 10, so you are now having 20 sin theta cos phi by r cube into ar cap 20 minus 10 cos theta cos phi by r cube into a theta cap minus plus 10 sin phi by r cube into a phi cap. Okay, now this is the expression for E bar, and it is the general expression irrespective of whatever may be the R for the given potential field V. Okay, now let us substitute the given point 2, pi by 2 and 0. So if you observe, R is 2 here, theta is pi by 2 and phi is 0. Okay, now if I substitute this, so 20 into sin theta, so sin theta is sin pi by 2, so it is 1, cos phi is cos 0, which is 1, so this term remains. So you are having 20 by r cube, so r value is given to be how much? It is 2, so 20 by 2 cube, so it is 20 by 2 cube would be 20 by 8, which is 2.5. So 20 by 2 cube into ar cap. Next, coming to the second term, cos theta. Theta is given to be pi by 2. So cos theta will be 0. So you need not worry about the second term because it's becoming 0. Next, coming to sin phi also. So sin phi is going to become 0 because sin phi takes a value of sin 0, which is 0. So you are remaining with 20 by 2 cube into ar cap. So it is simply 2.5 into ar cap. We evaluated E bar as 2.5 into AR cap. From this, we have a relation for D and E. So D bar is the flux density, electric flux density, and it is given by epsilon naught into E bar. So of course, this relation holds good only for free space. So of course, since the medium is not specified for our given problem, I can take the epsilon value as epsilon naught. Okay, so from this I can say that D bar, the electric flux density which is asked in the problem, is simply epsilon naught is 8.856 into 10 to the power of minus 12 into 2.5 AR cap. So 2.5 into 8.856 would give us 22.1. So it is 22.1 into 10 power minus 12. That multiplication I can replace with pico. So it is pico coulombs per meter square is the unit. Of course, the unit vector is AR cap. So 22.1 AR cap into pico coulombs per meter square is the value of D bar. So this is the final answer for D bar. Next, let us evaluate the B bit. So he is asking you to calculate the work done. So basic formula for work done is W is equals to simply force into distance, or it is force can be replaced with Q into E into distances. I will take it as DL. So I mean, of course, this is dW. From this, W is equals to integral Q, since it's a constant value, I can throw it out, Q into E bar dot DL. Okay, now this is the integral where we need to evaluate. Okay, so for evaluating this line integral, we need to establish a path. Okay, so the establishment of path in such problems is very, very important. So how do we establish a path? So this is, you need to concentrate much on this concept because this is the basis for our B bits. Okay, now we need to establish one path. So initially we are going to take from A is basically 130 degrees and 120 degrees. Okay, now, so what is the destination point we have? It is 490 degrees, 60 degrees. Okay, so now starting with the first change. So the first change is change in R. So the length element in change in R is dr. That means we are calculating, we are taking this length element at each change. So that means first we are considering the R change. So R is changing from 1 to 4. So we want the destination R value to be 4. So it is 4, comma. Now these values will not change. So that is 30 degrees and 120 degrees. So in this first change, what is it that we are evaluating? We are evaluating the change in R. So while we are evaluating the change in R, what is the length element? It is a change in R direction. So what is the length change in R direction from the concept of this spherical coordinate system? It is obviously dr. So in spherical coordinate system, the change in R direction is simply delta R is equals to dr. So we are taking the length element as dr in the first change. Next, coming to the second. So in the second change, we keep R constant. So we keep R constant. So it is 4, comma. Now theta changes. Theta changes from 30 degrees to the destination theta. So the destination theta is 90 degrees. So it is 90 degrees. And of course phi is constant at 120 degrees. And in the last change, okay, in the last change, it is 4, 90 degrees. That means there won't be any change in this R and theta. Now the phi value changes from 120 to the destination value of phi. The destination of value of phi in B is 60 degrees. So it is going to be 60 degrees. And what are the length elements in the second change? So if you observe the second change, here we are changing what parameter? Theta. So in spherical coordinate systems, what is the change in length in theta direction? If you remember this concept of spherical coordinates clearly, it is simply r into d theta. Okay, so r d theta is the increment, length increment in theta direction, and in the phi direction. So here r is not changing and theta also is not changing. What is changing? Phi is changing. So phi is changing from 120 to 60. So whenever phi changes, what is the change in length in phi direction in spherical coordinate systems? It is r sine theta d phi. Okay, so now let us evaluate this integral, line integral. Okay, so let us evaluate line integral now. So E bar dot dl would be simply, now first, in the first case I told you r will be changing. So r is changing from 1 to 4. R is changing from 1 to 4, and E bar is simply we are going to take E r, that is 20 into sine theta cos phi by r cube into what is the length element we have in the first change? It is dr. So the length change in the first in the first r direction change is dr. So dl is replaced with dr. Actually, strictly speaking, we are considering only the first of the three. Why? Because this is dr into ar cap, and this is E theta into A theta cap, strictly speaking. Okay, so we are not considering these two components for dr. Why? Because the dot product is 0 for A theta into dr ar cap, and similarly A phi dot dr ar cap will be 0. So we need not consider these two for evaluating the E dot dl in case of theta components and phi components. Now similarly, coming to the second one. Now in the second one, if you observe, it is plus integral. Now which is changing? Of course here theta is constant. Theta is taken to be 30 degrees and phi is taken to be 120 degrees. Next, coming to the second integral, second part. In the second part, in the second part, what is changing? Theta is changing. So theta is changing from what value to what value? 30 degrees to 90 degrees. So theta is equals to 30 degrees to 90 degrees, and you need to mention only the theta component. Why am I not mentioning the remaining two components, ar cap and a phi cap components? Because they will be 0 due to the dot product. So in the second part of the integration, we will take this a theta component, which is minus 10 into cos theta cos phi by r cube into what is the length replacement in theta component. Since the length variation in theta direction is r into d theta, so people will get confused here. So it should be not simply d theta, it should be r into d theta. Why we should substitute r into d theta? Because d theta is simply angle, it's not the change in length. So if I wanted to convert a change in angle into change in length by the formula s is equals to r theta, I will replace the length as r into d theta. So it is simply r d theta plus, of course here r is equals to, the final value of r is 4, and phi will take a value of 120 degrees. Okay, and final part of integration is, it is Phi variation. So phi is varying from 120 to 60. So phi is equals to 120 degrees to 60 degrees. Okay, so that the phi component you are going to substitute here. So phi component is simply 10 sine phi by r cube. Okay, 10 sine phi by r cube into what is the length component here, dl. In case of phi, it is r sine theta into d phi. So it is simply r sine theta into d phi. And of course, what are the values of r? R takes a value of 4, and phi, theta takes a value of, so what is the last value of theta we have? It is 90 degrees. So theta takes a value of 90 degrees. Okay, so this is how we are going to evaluate. Okay, now let us substitute the values and get the, so E dot dl would be, so now what is integral dr by r cube? It is 20 sine theta cos phi into minus 2 by minus, so it is n into n power n into x power n plus 1. So that is, it is x power n plus 1 by n plus 1. So it is r power minus 3 plus 1 by minus 3 plus 1. So it is minus 2 by r square, minus 2 by r square. And here r equals to, r varies from 0 to 1 to 4. Phi is 30 degrees and theta is 30 degrees and phi is 120 degrees. Next, plus, minus, we have got 1 r gets cancelled here, so you're having r square. Okay, now, so 10, we have got integral d theta. So what is cos theta d theta with the integral? It is minus sin theta. So minus 10 into minus sin theta is plus 10 sin theta. So it is plus, you can write it as 10 sin theta cos phi by r square. Okay, and theta varies from, you have got 30 degrees to 90 degrees. 30 degrees to 90 degrees, and r is equals to 4 here. R is equals to 4. R equals to 4 and phi equals to 120 degrees. Lastly, you got 1 r gets cancelled here once again. So you have got with r square. So what is integral sine phi here? It is cos phi. So plus 10 cos phi sine theta divided by r square, from phi varying between 120 degrees to 60 degrees, and r takes a value of 4 and theta takes a value of 90 degrees. So substituting the given limits, finally you'll be getting the expression for integral E bar dot dl would be simply, we'll be getting it as minus 60 by 32. Therefore work done on 10 microcoulombs charge is 10 into 10 power minus 6 10 microcoulombs into your E bar dot dl, which is minus 60 by 32. So in total it is simply 18.75 microjoules. Okay, so if this is about determining the potential difference, determining the work done if potential function is given. Okay, so in this way you are going to evaluate E bar, and after E bar you are going to evaluate integral E bar dot dl, and finally we arrive at the work done, which is product of E bar dot dl into the charge. And thank you for watching this video. If you are having any doubts, please give them in the form of comments. Thank you for watching my video. If it is found to be informative, please subscribe to our channel, ElecTV Education.